Dear students, today we discuss the program to convert your binary value to sine wave pattern, sine wave waveform. So this is a way how your DAC IC is connected to 8051 microcontroller. So it is indeed, it's a very important thing you need to remember. It's connected to port 1 to the D0 to D7 pins. Okay, it's a 8-bit DAC IC. So it will convert your digital value, will convert into analog in current. Okay, that current values, analog values, that will be converted into the equivalent voltage by using current to voltage converter. Okay, this is your analog values in terms of voltage. Remember, very important thing is port 1 is connected. That's why in program also we are using port 1. Okay, see now, to generate the sine wave, we need to represent the magnitude of sine of angles between 0 to 360 degree. So this is your sine signal, right? Sine signal. So 0, 90, 180, 270, 360. See, I need to know the magnitude of the sine of angle between 0 to 360. What is the maximum angle that you can decide? See, for example, in this program I took 30, then 60, then 90, then 120, then 150, then 180, then you can put up to 360. I need to know what is the magnitude of sine of the angle 30 degree. Then only that can be converted, binary values can be converted into the equivalent analog values. Okay, that you need to find it. So that you can choose. Okay, for here I choose 30, you can choose 10, 20, 40 based on your requirement. Another thing, you can see here maximum, this is a +1 I can consider. This is a -1. That means your +1 at 90 degree and -1 at 270 degree. So that's what it said here. Okay, maximum 1 at 90 degree and minimum of -1 at 270 degree. So I can take the +1 as a +5 voltage and -1 as -5 voltage. That means overall swing of 10 voltage. Overall voltage of 10 voltage with a variation of +5 and -5. Similarly, you can see the sine value is 0 at 180, 0 to 180 and 360. Okay, you can see here. Now, so this is important formula, like this is a formula to convert the your DAC input values. To find that, the formula is V out equal to 5 voltage into 5 voltage into sine theta. What is this actually? What is this actually? The 5 voltage, it's a base voltage. Then you need to trace the sinusoidal variation, right, that you added to it, right? So with respect to the angle, so that's why the 5 voltage is multiplied with the sine theta along with this base value. Okay, now what is a degree you need to take? So I took 30, 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Now you need to substitute this value in this sine theta and I find all the values, equivalent values with respect to degree. Then I multiplied this value with the 5 voltage, then I added with this 5. So this is the formula is given. So you'll get this V out. So this is your DAC input values. So now I'm going to do the scaling factor. Okay, we know that it's 2 power 8. It's a 8-bit DAC. So 256. Okay, so 10 voltage is a +5 and -5. maximum of 10 voltage, you can represent by 256. Suppose I want to represent for 1 voltage, it should be divided by the scaling factor of 10. You will get 25.6. This is for 1 voltage. I hope you understand. The 10 how you get, because maximum of plus 5, that is plus 1, and minimum of minus 1, that is minus 5, overall swing of 10 voltage. So 2 power 8, 256. That means 256 I can represent by 10 voltage. If you want to represent for 1, the scaling factor it should be divided by 10. So that 255.6. Okay, so that your whatever value you got in V out, okay, to find a DAC input values, these are very important. So your obtained V out should be multiplied by 250 to 25.6. You will get the equivalent decimal value. So that you need to find before going to the program. So very important. That is depend on this degree. Please remember. How many values you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. That you need to store in the some memory table while writing the program. Okay. So now we'll go to the program. See, now very important. I used sine. What is a sine? So you have a sine data, to represent from 0 to 360. For 30-degree step angle, you have a 13 values, right? I said right. You can see here. You have a 13 values here, right? So those values are stored in some memory location. I kept the name sine. Okay, I kept the name sine. Okay, the memory table is sine. There your values are noted. So it's a defined byte. Here you have a 13 values. It depends on the how much angle you are taking. Here I took for 30 degrees, so you have a 13 values. Okay, so now we'll go for the program. Move dptr hash sine. What is the logic here? See, please understand, while you are executing this instruction, a dptr will hold the starting address of the sine wave memory table. It will take only the starting address of the sine wave table. The rest of the address you can take by incrementing the dptr. That is the concept. After the execution of this instruction, the first value is fetched from the table, because the address is held by dptr. Okay, please remember, please understand, the dptr will hold the starting address of the sine wave memory table. So let me say 8000. 8000. In 8000, 128 is stored. This dptr will hold the, similarly you have a 13 address. Okay, okay, so the dptr will hold the address of this first value. Okay, the first value is fetched from the table with this address. Okay, so that is a very important to be remembered while writing this program. The dptr will hold the starting address of the sine wave memory table. Okay, now move R to hash 13. Why 13? Because you have a 13 values. To ensure that the 13 sine wave values to represent your 0 to 360 degree, the equivalent values. So that's why the R2 is loaded with 13 decimal. The 13 is a decimal. Now I'm clearing the accumulators. That means your A is 0 0. Now move CA at A plus dptr. You know that accumulator value is 0. Okay, dptr, you know dptr hold the address, right? Hold the address. So in that address, whatever data there, that will go to the accumulator. That will go to the accumulator. In that address, whatever data there, that will go to the accumulator. What is a move C? Move C is here to access code memory. So code memory, we are using this instruction. So I hope you understand. Initially we are clearing the accumulator. Now dptr, already I said dptr will hold the starting address of the sine wave memory table. Okay, now whatever content in the accumulator, that will go to P1. Why you want to send to P1? I said very clearly, whatever content in the accumulator that will go to P1, then only I can process it, right? Then it will go to the DAC IC. Okay, so I hope you understand, right? So now incrementing the DPTR, I have to fetch the next data. So this is for 30, then 60, then 90, then it's 120. So you want to represent all the values, right? Then only you'll get your sine wave, right? Then only you'll get your sine pattern of 360-degree, right? So decrement jump if not 0, right? What it will do, it will check the R2. If not equal to R2 is not equal to 0, it jump to the label next, because I need to represent all 13 values, right? Then only you'll get the pattern of 360-degree. So every time it will check if R2 is not equal to 0, decrement jump not equal to 0. If it will jump only if it is not equal to 0. So you know that while decrementing, so 13, 12, 11, 10, during the transition it will not be equal to 0. So every time go to the label, the data will be moved. So you will get the pattern of the sine. Once your R2 all the value 0, so that time the condition true. So this condition fail, it comes out. Then short jump sine wave, then again go to the jump of sine wave, again it will start the process. So this is a way how to get the sine wave form.